Good morning to you all. Today's session, unit number 5, the first topic, advanced propulsion systems. Okay, how many of you attended the last week's webinar series of rocket propulsion? Anybody attended from our classes?
Yes, a few of
Some.
them attended, sir.
Okay. Okay, I think yesterday also Dr. Jairam had one session. There he was discussing on the basics, almost all the basics. What we discussed in the classes only he was discussed, like solid propellant, liquid propellant, and he was talking about something called as a new technology. But it's not a new technology. It's an advanced system. It's already available. It's not a new technology in the current technology. Okay, anyhow, it is the advanced propulsion system. What was there in the earlier stage itself is still in the process of developments. But we can't say it is a new technology. It's an old technology. It's not old. It's not a traditional one like chemical propellant. Instead of using chemical propellant, we are using some other power sources to generate thrust. Hence, it is termed as advanced propulsion systems. So that way, that the unit talk this today's class starts with that. And the last unit starts with the concept of advanced propulsion systems. So from the name itself, you can define, as I said earlier we have the traditional systems. There were we were using chemical propellant for generating thrust. As you know, the objective of the propulsion system is to generate thrust so that the vehicle to move the vehicle in forward motion. That is the objective of any system of propulsion, maybe a rocket or maybe a breathing systems. So coming under the categories of by providing a certain kind of masses of the propellant with some energy sources, that energy tends to give some what is the liberated energy in the form of velocity, in the form of a jet. The velocity jet tends to give some thrust force acting at the end, so that we can able to achieve some propulsive effect or propulsive forces to propel the vehicle in forward direction or in upward direction. So coming to that, in the topic with advanced system, like not the normal traditional sources like chemical propellant source, chemical energy, here we are using different sources of energy readily available in nature that is meant for using the say concept called as advanced propulsion systems. It basically, broadly, it classified into three categories. First one is the based on sources with electricity. It is called as electrical propulsion system. Based on source of energy, the source energy received from sun, it's called as solar propulsion system. And the third one, the energy sources from the nuclear atoms, uranium, thorium, and other nuclear atoms, nuclear energy sources, we can able to get some thrust generation. Hence, it is termed as nuclear propulsion systems. So compared to the normal traditional chemical propellant, like fuel and oxidizer, here we are having the source of energy received from sun and received from the electric power, and the sun received from the nuclear energies. So there we have three different broad classification like solar propulsion, nuclear propulsion, and electrical propulsions. So as far as the basic broad classification, it can be further classified into based on the application and development of the principle of operations. There will be some different variants coming to the all these category of nuclear, electric, and solar. So coming to the first categorization, coming under that electrical propulsion system, we have three major classifications. One is the electrostatic propulsion, second is the electrothermal propulsion, and third one is the electromagnetic propulsion. So name itself you can define. Electricity along with the static force, the propulsion energy generation, that is called as electrostatic propulsion. So if you are using electricity along with the thermal energy source, then we can able to get some force, propulsive force or thrust. Hence, it is termed as electrothermal propulsion systems. The last one with using electricity as well as the magnetic field principle, then hence it is termed as electromagnetic propulsion systems. So these are all the major classification coming under the category of electrical propulsion system like electrostatic, electrothermal, and electromagnetics. So all the three classified systems operate with the basic principle of the energy received from the energy sources, the electricity in the form of voltage and current as a power. That is used for generating thrust when the propellant is heated up. When the propellant is generating energy by usage of this electricity along with the static force, electricity along with the thermal system, electricity along with the magnetic field, and thereby with using the principle called as different principle operation that coming under this category of electric propulsion or like electrostatic, electrothermal, and electromagnetic. Again, this electrostatic, we may have two variants, two methods. We can say two methods. The first method of electrostatic propulsion system is nothing but ion thrusters. This is using ion principle that is called ion thruster. Second type of second category or second application of second method of electrostatic propulsion is Hall effect thrusters. That is we had one concept called a Hall effect. Already we had in your basics science studies, physics and all. If you don't know, you can remember recall it. But it is there already in your school science, basic sciences what you learn in your school as well as in the first year physics. So there we have with the basic of ion propulsion, we have electrostatic and the electrostatic categorization. We have two methods called as ion thruster and Hall effect thruster. First one is based on ionization principle. Second one is based on the Hall effect principle. Then coming under the electrothermal propulsion system categorization, we have arc jet and resistor jet. So the arc is meant for, as you know, arc is we may have had the crossover across the topic or this called as arc. You know, everyone knows what is an arc. So this arc is meant for heating the propellant to generate thrust. Hence, it is termed as arc jet propulsion system. Similarly, the resistance, the changes in the thermal resistance, that tends to give the heating the propellant or generating thrust, then hence it is called as resistor jet. Then our electric arc and the electric resistance along with the thermo heating system tends to give some effect of propulsion forces. Hence, these methods are known as arc jet propulsion system and resistor jet propulsion system, and be coming under the major classification of electrothermal propulsion systems. The last third category or categorization coming under that the electrical system is electromagnetic. So there we have electricity as well as magnetic field. Both the field, electric field and magnetic field tends to give some forces acting. That force or principle is meant for generating thrust. Hence it is termed as electromagnetics. Under that we have variants like MPD thruster and PPD thrusters. PPT. So that is first one is magnetoplasma dynamic thruster. Second one is pulsed plasma thrusters. Again from the name, pulsed generation tends to give plasma with high energy, high temperature, generating thrust. Hence it is called as pulsed plasma thrusters. Similarly, magnetic field tends to give some high energy, high temperature plasma in the form of dynamic effect that is called as magnetoplasma dynamic process. There will be called as one force known as the Lorentz force. That principle is employing in this system. So we'll be going to discuss elaborately in the forthcoming topics. All these electric propulsion system like ion thruster, Hall lever thruster, arc jet system, resistor jet system, MBD and PP. Like that, 2 plus 2 plus 2. So totally six methods of advanced propulsion system coming under the electrical propulsion system. The next one is the nuclear system. Again, nuclear, as you know, the energy source is nuclear atoms, uranium and all. Like, and the nuclear energy system is meant for generating thrust. The atoms, the uranium, they have nuclear fusion, and isotope decays. Like that, we have three method or three different categories of the generation of the energy by using nuclear atoms. Can anyone answer for this question? What is meant by nuclear fission and what is meant by nuclear fusion? Anyone? Nuclear fission
The
and
nuclear
nuclear
fission
fusion.
is when an element with a higher atomic number splits into different two different elements, giving out energy. Nuclear fusion is when two elements combine together and consume energy to form a higher atomic number element, and they are radioactive.
Yeah, perfect. That's correct. Okay, as I said, adding of a combination of nuclear atoms together tends to give some energy as fusion. If you split into atoms, that is called as fission. So that based on that principle, using that nuclear radioactive elements like uranium, thorium, or plutonium kind of elements with isotopes and isobars. You already had your physics and all isotopes, isobars of the atoms. Use that 23592, use 23892 like that. So that way, same. What is isobar? Anyone? What do you mean by isotopes? What does it mean with the isotopes of yeah, atom, that uranium? What does it mean?
Same atomic number, different atomic mass is isotope.
Yeah, perfect. Okay, correct. So same atomic number, they have atomic number and atomic masses. So one 92 is the atomic number and the other one is atomic mass. We have two combinations. So U2 92 to 35, U92 to 38. Like that, we have different isotopes. So that and all need to take into account in the physics. Without the nuclear energy kind of operation, nuclear fission and nuclear fusion, thereby we can able to achieve some energy that will be used for generating thrust along with the nozzle generation. So everywhere we are using a nozzle. So nozzle is meant for generating thrust for all the application we are using it. So based on that fission and fusion application, we may able to generate energy. Again, there will be two classification: nuclear thermal and nuclear electric. So they along with the nuclear energy, we're adding with the thermal system, it is a nuclear thermal system. We're adding nuclear energy along with the electric, it is called as nuclear electric. So that is the that is the discussion on nuclear system. We will discuss in deep in next sessions. So coming to the last third one, major classification, solar the propulsion system. So as you know, the energy source is sun. From the sun, naturally available source, the sun. From the sun energy, solar energy, we are receiving energy. We are collecting it by using parabolic collector or some system of radiator systems. Tends to having that will be used for heating the propellant. So always we are allowing propellant to flow in the system, all the systems. So what is the thing is the way the energy sources receiving will be used to heat the propellant. Thereby, the heated propellant generating energy in the form of kinetic energy in the form of jet through a nozzle, obtaining thrust. So that's the principle, very simple principle. So these are again solar also have we got solar electric and solar thermal. So you are using along with the solar system, you are using electric system. It is solar electric system. You are using solar thermal propulsion. We are using is called the solar thermal propulsion system. So these are all the overall view of the basics or the overall idea of the advanced propulsion system. So different source of energy other than chemical energy is used for generating thrust. Hence it is termed as advanced propulsion. It's not a new technology. It's in processing. It's in progress. So many people are doing projects. Now our students are also doing some projects like projects in the final year using this principle. It is compared to the chemical system. It is easy to develop and fabricate and do the analysis compared to other systems. So with that basic discussion, we'll be entering into the topic, first category, electric propulsion system. So already discussed, I already told you basic principle. We're using electricity power source in the form of voltage and current that is meant for heating the propellant. So there are the operative principles, three stages. So as I told earlier, a charge particle in the form of gas particles. There will be we have three stages. The first stage is the creation, second stage is the acceleration, the third stage is the expulsion. So creation of the charge particles, first one. Second steps, acceleration of the charge particle. Third one, expulsion of the charge particle through the nozzle. So by using electricity. So we have able to get all these functions by using electricity. So whenever you are applying electric power in the form of between cathode and anode, connecting between the propellant cases, we may able to heat the propellant. They process the electricity to generate thrust. So there will be three creation of the charge. First, you want to create the charge particle. Then second one, you want to accelerate the charge particle by using some setups, some methods. The third one, you want to expelling the charge particle through the nozzle. So one it is created, then it is acted the high velocity, then expelling to the final nozzle exit. Thereby, with the high velocity, jet will tends to give thrust at the end. So here we are all discussing more on thrust only, not on specific impulse. Okay, so this is the case here. Relative thrusters have significant advantages over other types, extremely high specific impulse ranges. But the counter drawback of the system is here we can have low thrust ranges. Thrust is low, but specific impulse is high. That depends on the mass flow rate of the propellant. So as you know the relation thrust to specific impulse. Specific impulse is given with respect to thrust to weight flow rate of the propellant or the mass flow rate of the propellant. So that defined, the mass flow rate of propellant defined. The thrust is low, even then thrust is low, we can able to achieve high specific. If even then thrust is high, we can able to go for low specific impulse. Everything based on the mass flow rate of the propellant. So coming to this electric propulsion system, but thrust level is low range, but specific range is higher compared to the traditional system. Not only traditional, compared to other advanced system. Electric propulsion system is having a high specific ranges and the low thrust ranges of generation. That is the one is advantageous one. Other one is the same way it is disadvantageous cases while using the charge particle with the three methods, three stages like creation of the charge particle, acceleration of the charge particle, and expulsion of the charge particles. So that is the basic principle. That's the basic operating principle of a electric propulsion system. So same as if we go for the chemical propellant, what is the concept? We are using the propellant to allow to flow with the oxidation and fuel. Then we are heating, then accelerating, then expelling it. So same way here also we are creating then the charge particle with the use of electricity. Then the charge body will be accelerated with some providing some setups or systems. Then we will be expelling it through the nozzle by using the method called as some different principle. That is coming under the principle of a electric propulsion system. Then the with respect to the electric system, this major features you can say important features of this electric system like high exhaust speed. So already I told you we have high specific impulse, so much greater than in conventional chemical rockets. That is the major feature. Much less propellant consumption, much higher emission fuel addition, but the fuel utilization is much higher. But propellant consumption is less. That will be some two different concept. So here we don't have any oxidizer. Here we have only fuel, or in the form of gas only we are allowing. So that will be used to consume the less propellant. Consumption is less, but with the less consumption of propellant, we can able to use more fuel to generate thrust. Similarly, continuous propulsion, there is no discontinuity. So we can apply a smaller thrust, small range of propulsion for a longer duration. The duration of operation is very longer duration. Even then, the low thrust level of operation, we can able to achieve this for the application of the longer duration or longer time operations. So it is very flexible for the mission flexibility. We can go for interplanetary travel and defense applications. Endurance is high, so we can go for the commercial satellites also we can use it. So these are all the major features of electric propulsion systems. So already we had three subdivision or subclassification or variants of electric system like electrothermal, electrostatic, and electromagnetic. So already we had electrothermal. Already I told you, propellant is heated, electrically heated through a wall by a electrical arc or discharge. Similarly, electrostatic charge particles or ions accelerated by electrostatic forces. The third one, electrically conducting fluid or the gas or the propellant accelerated by electromagnetic and pressure forces. So these are all the basic principle of this. The first one is coming under the arc jet and wall jet. Resistor jet is also known as wall jet. So it's the thermal resistance due to wall. Other one is due to arc discharge. So standard distance. So the propellant is electrically heated through wall by arc or by discharge or electrical arc. So if you go for wall, it is called a resistor jet. If you go heating the propellant by using an electric arc, that is called as arc jet propulsion. The second one is electrostatic by due to of ionization. I already told you ionization method, ion propulsion, ion thruster. Then one more propulsion system is what is the other method under the electrostatic? Anyone? Can anyone answer for the question? What is the other? Hall effect thrust. Yeah, that is both the system employ with the system of static forces, electric force along with the static force, electrostatic forces. So third category is electromagnetic field combination, electric field, magnetic field. Both the field are operating. With the due to that two field operating system, we may able to get some forces. So like Lorentz force, we will discuss what is that. So that kind of forces tends to generate thrust, pressure forces, and electromagnetic forces. With that, we can able to create. With that, we can able to accelerate. With that, we can able to expel. So basic principle for all these systems, electrostatic, electromagnetic, and electrothermal, are creation, acceleration, and expulsion of charge particles. First, you go to create the charge particle by using the electricity power supply. Then you go to accelerating the charge particle by providing some grids or some setups or systems. The third one, we go to expelling the charge particle through a wall, through a nozzle to generate thrust. So basic principle common for all the three systems. But only difference is the first one is with the static force along with the electricity. Second one, thermal force along with the electric system. Sorry, thermal electrothermal means electric system and thermal, and the third one is electric along with the magnetic. So we have three different sources, different methods. Combination tends to give the propulsive force as in the form of thrust. Hence, it is termed as electrothermal, electrostatic, and electromagnetic propulsion systems. So these are all the major principle with along with that basic principle of electric propulsion system. Three categorization. So start with let me start with today's session. I'm going to discuss only on electrothermal with the resistor jet and OR jet. So the third topic, let me start with the electrothermal propulsion system. So very simple, I already told you, electricity or electric power is used to give energy or add energy to exhaust the heated propellant in the form of the exhaust gas with high energy through a nozzle tends to generate thrust. Simple. So comparison. So we got two methods. One is resistor jet, second one is OR jet. So resistor jet is nothing but it is a wall kind of thing. So we have the catalytic decomposition. In this system, thermal, as I told, mentioned, it is thermal. So we have thermal energy system. How to achieve thermal energy system here? Using a chemical is known as hydrogen. The hydrogen is used here. There we are going for catalytic decomposition of the hydrogen that will be augmented or improved or increased or augmented with high electric power heater. So we are using electric power heater or electric power wall, heat wall. The wall is meant for heating the propellant. So then it is called as resistor jet method. Thermal resistance generation due to the wall heating. The range of power is in the range of 800 to 5000 watts power, voltage into current. So power is 5,000 to, sorry, 800 to 5000 watts. So that is the thing is the propellant or hydrogen is used here. Then it will be decomposed by using catalytic decomposition by the application of the thermal resistance changes with respect to the electric power supply by a wall, resistor wall. That is called resistor wall. So then hence it is known as resistor jet system. So the range of power we are using is 800 to 5000 watts. So if you go for object, the next method, here we have arc at the nozzle. So on the nozzle throat with the application of the electric power, we can able to get an arc at the nozzle throat. So that will be tends to add some energy to the exhaust. So whenever the propellant is passes through the system, vaporized propellant or the gaseous propellant passes through the system of a nozzle, at the throat we will be having a high velocity or high voltage. So that the high voltage arc at the nozzle throats will adding the thermal energy along with the electricity by the application of electric power tends to generate thrust. So hence it is termed as arc jet propulsion. So you have to compare how it differs. So both are endothermal, both are using the propellant to flow. So only difference is the first method arc jet or a thermal, sorry, the resistor jet we are using thermo resistance coil or resistance coil, resistor coil or wall that is meant for heating the propellant. When it passes, the current is passed through the system. Second method, when the current is passed through the system, there will be an arc is forming. The arc formation is at the nozzle throat. That portion, when the propellant passes through the nozzle throat arc, that arc is meant for heating the propellant to expelling it to the outlet. So that we can able to generate thrust. So that's a simple way of comparison, simple way of generation of the thrust. Then these electrothermal thrusters differ from both electromagnetic and electrostatic systems due to this design only, operational design only. Other than that, principles are same. Electric power system, electricity are using creation and expulsion, expulsion only propellants are heating up, everything same, except the operational design only differs. So electromagnetic and electrostatic system propel charge ions through the use of electric and magnetic fields, while electrothermal system heat the propellant. You can see the comparison. Here, electrothermal systems, the electro system, it is heating the propellant, whereas the charge ion particles by the use of electric and magnetic field, it is used to propel the vehicle. That is the difference. So that is the thermodynamic propulsion systems. In a typical operation, a propellant is electrically heated, which increases the pressure and expands the gases, forcing the masses of the nozzle and providing thrust. Very simple. So what is the thing? Propellant is electrically heating, creation of the charge particle, electrically heating, and increases the pressure and expands the gases, the accelerating, then forcing the energy is passing to out of the nozzle in the masses through propelling the thrust. So again, it comes in the concept again: creation, acceleration, and expulsion. Creation, acceleration, expulsion. Creation of the charged propellant, acceleration of the charged propellant, heated propellant, and expelling of the charged heated propellant with the high velocity to generate thrust. So very basic concept, common principle for all these electromagnetic, electrothermal, and electrothermal systems. So the same principle is we are employing in arc jet as well as in resistor jet systems. So first I start with the arc jet propulsion. You can able to understand. You can able to understand this diagram itself. You can able to see here. We have one anode. We have one cathode. Then the propellant will be injected as a form of a fuel through this system, the space available in the cathodic entry of the system. So what will happen? Due to the potential difference, when the electricity power supplies with the anode and cathode, that tends to give some changes in the formation of the arc at the throat of the nozzle. You can see diffuse or reattachment at anode. So that is the cause. When the propellant passes through that, injected propellant passes through this arc, it will be heated up. So once it heated up, there will be coming out through the nozzle at the end. After the end portion is the nozzle position. So through the nozzle, it is expelling out. So electrothermally heated propellant will expel out through the nozzle exit to generate thrust. So due to the reason of potential difference. So what is the principle? Potential difference, charge the particle or the propellant will be passes through the system. So creation of the charge particle, then it passes through the in between anode and cathode. So because of the triggered motion tends to give accelerating the propellant. Then because of the difference in the potential, will tends to form an arc at the anode. So that propellant passes to the arc, heated up, then taken at the expelling out in the form of mass out to the nozzle in the form of electrothermally heated propellant that tends to give a thrust. Very simple operating principle. You can able to easily understand how it works. So that is the basic diagram. So this is the actual arrangement how an object system operates. So you can able to see that we have one propellant tank. From the propellant tank, we are allowing the propellant to flow through a pump feed system. So already as we told, we have vertical power supply. There will be positive, negative, like a cathode and anode. So at the cathode region at the center point, we'll be having a critical electrode, and the other one is anode on both sides, up and down. So between we are allowing the propellant to flow. There will be a arc forming at the anodic region at the nostril throat. There will be we are getting. So when we'll be having this system, then tends to flow the back, forming accelerated plasma with high energy, high temperature. Plasma, it's high temperature. So because of this potential difference between the cathode and anode, tends to give some accelerated plasma with when it passes through the arc, the propellant is geared up. Then arc tends to generate heating the propellant, which is used to accelerating propellant that is used meant for expelling, or accelerated propellant will be expelling to the nozzle exit through the system. So one more system we are additionally we will be having in that diagram, that is a pump along with the propellant cooled chamber wall with the radiator. So that is meant for cooling the system. For an example, whenever the arc is forming with a high energy or high voltage differences, so we go to cool down, or it will be able to cool down the chamber wall always. Otherwise, it will have some problem in the damage of the chamber wall. For the purpose, we are using that allowed propellant for the recirculation with the propellant cooled chamber wall. So here the same propellant will be using for cooling the system by when it pass through the radiator. Can anyone say what is the use of a radiator? So we are using house, cars, automobile, car and four wheelers. Yeah, it is meant for cooling. Same as radiator, what we are using in our car and all, like automobiles. So it is a cooling. So the propellant already heated up. That will pump us through the system when it passes the radiator.
Sir, we can't hear you.
Circulated in the okay. So we have the pump. There's a pump is meant for that will be used to pass through the heated propellant, allowing the pump to flow the radiator. So radiator is meant for cooling the propellant, cooled the chamber wall. that is allowed to flow through the region of oxygen. You can able to understand with the help of the arc, directional way of arrow mark is available. So very simple. So electric power supply, propellant tank. Through the propellant pump system tank, propellant will be pumping. So we have electric power supply anode and cathode, cathode at the center and anode on the both the sides. So when the power supply given, due to the potential difference with the negative and positive electrodes tends to give some difference in voltages, then arc is forming. So once arc formed, propellant is allowed to flow by a pump, it is killed up. So the killed up propellant will be axed to the inlet with a nozzle. Addition to that, if you want to go for cooling system, you will be having a recirculation nozzle wall coolant method. So that is meant for cooling the propellant, cooling the wall as well as the chamber wall, nozzle and chamber by using a pump and along with the radiator that is meant for cooling the propellant to cool. It is meant for maintaining the temperature of the chamber wall and nozzle. So this is the working of an electrical oxygen propulsion system. So, oxygen systems or oxygen thruster is a form of electrically powered state propulsion in which an electrical discharge, it is known as arc, is created in the flow of the propellant. Typically, we are using hydrogen or ammonia for these cases. So, additional energy to the propellant so that we can extract more work out of which the propellant at the expense of the power consumption and higher cost. And the thrust level available from this system is very low compared with chemical. Earlier I told you like we have higher specific impulse range, but lower thrust levels, more fuel efficiency, and less propellant consumption. When the energy is available, objects are very suited to keeping stations in orbit and can replace monopropellant rockets. Thus, it was mentioned earlier, like it is very suitable for the what is the defense as well as interplanetary operations. Very, very suitable. Commercial satellites also you can use it. So all that is more suitable for commercial satellites and interplanetary missions and defense applications. Then when the energy is available, objects are well suited to keeping stations in orbit as well as it can replace the monopropellant rockets what we are already using in the space orbit operation, spacecrafts. So compared to other chemical, it is low thrust. Low thrust. Even then, we can have high specific impulse with the use of the more fuel utilization with less propellant consumption. Fuel will be more used, more in the sense efficiently utilized. That is the thing. Okay, with that case, it is more suitable for spacecraft applications. So these are all about the uh, electric system with the an object propulsion concept.